All right, so this week we're starting a brand new topic, which is strings. We've implicitly covered strings up to this point already by using them, right? If you want to print out hello world, you just put the string inside of two double quotes and you've got yourself a string. But now we're actually going to start manipulating them. And so the very definition is that a string is simply a sequence, and that means that it's ordered of characters. And C and Java treat these very, very differently. In C, a string is an ordered sequence of ASCII characters. So you are limited to the ASCII text table, right? ASCIItable.com. In Java, however, they're full Unicode characters. And in the spirit of Halloween here, we've got pumpkins and ghosts and everything, right? CJK fonts, emojis, everything that you're used to seeing in texting now, right? Those are all Unicode characters. Internally, Java represents them in UTF-16 encoding, if you're familiar with that. Most of the time, I think, but if it's just plain ASCII, there's another standard for it. But there are two other major differences between the two languages. In C, strings are null-terminated arrays of characters. So we just got done talking about arrays, and now what we're going to do is we're going to apply all of that knowledge to strings. But the big difference is that if you've got HELLO, you've got this extra character at the end that terminates it in C, because in C it doesn't know HELLO, where's the end of this string. It'll just keep going on forever until it sees what's called a null terminator, and we'll talk about that here in a second. In Java, however, they're full classes, and internally they are byte arrays inside of full classes. Right? That is a string. There's a string class. Okay, so Java, it's going to be a lot easier to work with, and C, it's going to be a little bit more difficult to work with. So therefore, we will start by covering strings in C. And as I said, they are null terminated character elements in an array. Right? In C, you have characters in the array, but at the end of the array, you have a null terminator, right? That is this thing right here, this \0, okay? Now, if you look this up on the ASCII text table, you'll see that this is the very first character. In fact, let's go to ASCIItable.com or whatever, right? And at the very top here, NUL or null, that's the null terminating character right there. This decimal value of 0, hex, octal, they're all the same. It's all 0. Now, it's not 0, right? So it's \0. It is not 0. That is this thing right here, 0, right? It is not the end line character, right? The end line character is /n. And if you look it up, I think it's 32 or something like that. Where is it over here? Nope, 32 space. It's somewhere over here, line feed or whatever it is, 10 or something like that, right? But it's a /n. It is not null that you're familiar with, NULL. Null comes into effect when you're talking about pointers. NULL is a pointer value that points to the null reference value. This is completely different. It is a character, right? And so you do have to be careful that when you're at the end of a string in C, that's what needs to be there, not one of these other three things, right? Although they are very similar. So now let's just go ahead and get into it over here and start declaring some string values here. Char, message, right? That's going to be a regular old array, right? But it's not an integer array, it is a character array, which makes it a string. Now you can immediately assign this if you want to. Hello world, or hello world, exclamation point, exclamation point. I'll leave it like that. There we go. And now you've got a string with those contents. Now, how long is that string? In other words, how many characters is that string actually in memory? All right, I see 5, 6, the space does count, 7, 8, 9, 10, 11, I think I miscounted there, 12, 13, is that it though? Yeah, 14. Why? Because there is this invisible character at the end that automatically gets inserted for us. Okay? Strings are also mutable. In other words, you can change them. Strings are mutable or changeable. Right? So I intentionally left that as a lowercase h. Let's go ahead and set it equal to an uppercase h. How would I end up doing that, by the way? So what index is that lowercase h at? 0. And how do I set it? Do I set it like this? Oops. All equals uppercase h. Now, double quotes. Is that a character? Nope, that's a string, right? So how would I set it to the character uppercase h with single quotes? And then you can print it out. Printf message is equal to %s. I think we've shown that before. The %s is the placeholder for a string value. So let's go ahead and output this message. Right? So, oh, you know what? I think I'm in the wrong one, but that's okay. We'll go ahead and do it like this. Demo. Right. A.out. There you go. And now it's hello world. Right? Now, if I printed it out before, then you'd of course have seen that it's lowercase h, right? So let's see that that change did in fact have an effect. It changed it to uppercase h. All right, so what if I were to do something like this? How big was that, by the way? How big was the 14? Okay, so let's go ahead and set the 14th character to be another exclamation point there. In other words, 3 exclamation points now. Is that valid? All right. No, why? Yeah, now it's missing the null terminating character. Right? Let's see what happens and what the effect of this is. Right? GCC, and it's probably not going to show up here. Oh, okay, there we go. Excellent. Stack smashing event. What happened? This string was located in the stack in one of our stack frames. It was of size 14, and so we had enough room to overwrite that exclamation point. And so what happened is that there was no null terminating character anymore. So when it goes to print it, it's going to print out hello world, exclamation point, exclamation point, 3 of them, and then it's going to keep going. And it's going to smash into our own stack. Let's actually take a look at this in our visualization, or visualizer here. Right? We'll walk through it line by line. Hopefully it'll let us, because yeah, it is. It's airing out here because there's a core dump of some sort there. It's not going to let me do this at all. Oh, come on. All right, there. Now it'll let me do it. Right, I just had to rewind it. All right, so there's the original message, and as we predicted, it is of size 14, 0 through 13. And what is that last terminating character? C automatically puts it in there for us with this kind of declaration. And so when we print it out, of course, we get that message. When we change the first character, of course, that becomes an H, a capital H. When we print it out, great, fine. Now, when we, oh, actually, I did the entirely wrong one, right? What did I should have done 13 here, but you get the same idea. Right? I miscounted. There are 14 here, but the 14th one is out of range here. Let me go ahead and edit this code and see if it changes anything if I just change this to 13 here. We'll do the same thing over here just as a quick test. We're getting rid of that null terminating character, which makes it an invalid string, and we got away with it here. We ended up not smashing our stack, but it is no longer a valid C string because there's no null terminating character there, right? Probably we were getting into memory that was 0 bytes, and so we ended up having a null terminating character there, but you're not going to always have that luxury. In fact, if we make this much larger, message, right, 100, right, come on, is equal to hello world, exclamation point, and then we'll terminate it like that. Right? In fact, let's change this. Let's change this to my name, Chris. There we go. All right. Now, how big is that actual array? 100, right? So we're allocating more space over here than we need to. So when we do something like this, it only fills up those first few characters. So let's edit this. And we'll see that this is actually of size 100. Right? It's just that it's been initialized with my name and a null terminating character after that. Oops, sorry. Char. There we go. Call them chars, but or cars, right? Characters would be cars, but we just have a different pronunciation when it's abbreviated like that. Oh, come on. Why is it? Okay, but more than 10 seconds. Unknown crash, overload, or bugs. All right, fine. I don't know why it's not working. All right, anyway, we have plenty of room to grow here, right? I could add on stuff to this. I could say name. So now how big is it that I see? 5, 6, 7, 8, 9, 10, 11, 12, right? So I could say that the 12th one is going to be, you know, I don't know, an exclamation point here. And let's go ahead and print this out now, what my name is. I do need chars here, right? A char there, name, and then I'll go hello, oops, hello, and then I'll print my name here. Let's go ahead and see what that does. All right, oops, char name, what did I do? Oh, duh, single quotes for single characters, there we go. All right, there we go, and let's go ahead and run it. There we go. I had room to grow there, and I got lucky. Because what happened? There's Chris Burke, and then there was a null terminating character. But I overwrote that null terminating character with an exclamation point. I just got lucky that there happened to be another null terminating character after that. Let's see if what would happen if I didn't get lucky. For int I equals 0, I is less than 100, I plus plus. Let's go ahead and print out each and every single character in that array. So printf, to print out a character, it's simply going to be %c, right? And it's going to be name sub I. Okay? I'm probably not going to always get all that lucky. Right? Looks like it's all, okay, there we go. There I am, Chris Burke. All right, looks like I did get pretty much lucky here because these are all null values, right? So what if I want to bump this up to, I don't know, 1,000? 1,000? Right? GCC. Come on, I can't always get that lucky. Okay, so apparently this compiler is bailing me out by null terminating out the entire string. So I got lucky, right? You're not always going to get lucky, and you're not always going to have the compiler bailing you out like that. So be careful. If you're going to do something like this, and add on to an array, one, you need to know that it's big enough to do so, and two, you need to make absolutely sure that it's going to be null terminated by explicitly putting in that null terminating character. Like that. Right? Now this is absolutely safe. Right? There we go. Right? Before it was safe just by coincidence or by virtue of the compiler saving me from myself, but now it is absolutely safe because I'm explicitly setting that null terminating character. Okay? Well, okay, I want to assign it afterwards. I want to, I want to reset. I want to reset my name to my full name. I want to say something like name is equal to Christopher Michael Burke. There we go. I want to do something like that. It's not going to compile, right? Because you can't reassign a string value after it's been created. Why? Because this is a memory address, basically. This thing is sitting somewhere in memory, and I'm trying to make that thing point to that thing over there. And it's not going to work, right? So to do this, I can't use the assignment operator. I need to use a function instead. And that's going to be str cpy. What do you think that stands for? Str stands for string. Cpy is copy. I'm going to copy into name my full name here. And I'm going to go ahead and grab all of that so I don't have to retype it. There we go. Now, is that string big enough to hold my full name? Yeah, 100, it's good. Not only that, but strcpy is going to put in that null terminating character for me. It's going to copy everything. It sees that null terminating character at the end right here, and then it copies that as well. And then it's done. Okay? So that I can actually print this out again to see that it has changed. GCC. Oh, and then what's wrong? If you're going to start working with strings, you now need to bring in the string library. So we'll do that up here. Include string.h. strcpy is a function in the string library. We're going to look at a couple of dozen of these, well, half a dozen of these functions, but there are a couple dozen of these functions in that library. Okay. All right. Now let's see if that works. Great. Run it. Come on. There we go. There's my full name. Right? What if I did not have enough space for that? What if it was only, I don't know, 20? Right? And I printed out hello the first time. Oh, cool. It's actually going to warn me about that. Writing 27 bytes to a region of size 20 overflows the destination. Right? I didn't even have to use the wall flag on that, and it warned me about that. It's not always going to warn you about that, especially if it is a dynamic array, which we'll get to here in a second. But it's just a warning, so let's go ahead and try to run it anyway. Right? And there, stack smashing event. Why? Because it is stored in that stack frame, and I am exceeding those 20 bytes that I allocated for it, and it's not going to work. So let's go ahead and bump this up to 100 so that it'll work again. Right? Ignore that. I don't know why it's having problems today, but let's go ahead and grab all of this and put it into the notes, right? Before it completely dies. Right? Okay?
I'm showing off the print statement in the console, the question marks.
Oh, good. Oh, it is showing up. Cool. Right? So we've corrupted memory at some point. Where did we corrupt the memory? Let's undo this. What? Several prints ago it started happening, like where, right here, there, net valid, no. And so what? Now it's manifesting itself differently. We've corrupted our memory here, so we've got a bunch of question marks here. Those are ASCII characters that are not printable. You know, if you go to, I shouldn't have closed it, but let's go back to the ASCII text table, right? So obviously it's getting some sort of values here that are like over here, 0 through 31. And for example, you can, like a bell. That's not a printable character, that is a signal to make a ding, right? And if you were to print that out, in some instances, it would actually ding on your terminal. Because it goes back to the typewriter days. ASCII characters were established in the 40s or 50s or something when everybody was still on a typewriter. And when you get to the end of the line, what happens? Ding, and then you push it all back. And so all these things have a corresponding idea with respect to typewriters. Vertical line feeds versus a new line feed, right? Device control 1, 2, 3, 4. They used those for some reason way back when. But these are all unprintable characters, and since we've corrupted our memory, it's printing some of those values, and you know immediately that ain't working. In fact, if I ran valgrind on this, GCC it with the G flag, right? Yeah. And then let's go valgrind on this. It'll come out with a report of exactly where I did that. So I've got at least one error here in one different context. It is one, that's a memory leak, so a heap, whatever. Here's what I want. Up here. There are uninitialized values there. So it happens somewhere on line, where is it? Line 23? That's in printf. That's 33. Sorry, 23. Where did you see that? Okay. Somewhere in main. I don't know why it doesn't have a line number on it, but whatever. Right. So it's because we've corrupted memory. I wonder if we just ran it straight again, would we get the exact? Yeah, we're going to get different corruption now, right? Because it's undefined behavior. So now I'm getting different values. If I run it again, I get different values because anything goes, anything can happen. Right? Maybe eventually it makes sense, right? But it doesn't here. Right? All right, so assignment operators. Again, or the string assignments. After the initial declaration, you can manipulate individual characters like we were doing, but you cannot reassign the entire contents of a string using the usual assignment operator. Right? The usual assignment operator is a single equal sign. Instead, use strcpy. And it's in the string library, right? Here is the function signature for it, right? And now let's go ahead and actually digest this a little bit. The first one is the destination. The second one is the source, right? So the first is the destination. I'll just go ahead and expand it out there. which is a char star, so it is a function, it is a character pointer. The second is the source, right? So it copies from the source to the destination, right? Some other assumptions here, source. It assumes the source is a valid, null terminated string. If it is not, then anything goes, undefined behavior. It also assumes the destination is big enough to hold the entire string plus the terminating character, null terminator. If that doesn't happen, it also is undefined behavior. Anything goes. Also, I want you to notice something about the source. There's another key word over there, const. What does that tell you about the source?
Cannot be changed.
Right, it cannot be changed, it is read-only. Source is read-only because of const. Well, why doesn't destination have a const on it? Because you are going to be writing to it. Right? If it has const, then of course you wouldn't be able to write to it, and you'd be stuck dead in the water. Right? So again, all of those assumptions have to be there. Right? However, at the end, it will copy the entire string and add the null terminator for you, right? If everything goes correctly. If it's big enough and the source is null terminated, it'll copy all that stuff over for you, right? There's another useful function called strlen that will tell you how big a string is. strlen stands for string length, exactly. It returns an integer indicating the number of characters not including the null terminating character. So let me show that to you over here. All right, let's go ahead and create, well, here, we'll stick with my name here. Right? And I won't initialize this. Instead, what I'll do is I'll just leave it like that. And then I will copy over my full name. There we go. Using strcpy, print it out. And now let's go ahead and capture the size of that. So strlen of name. Right? Now, the array itself is of size 100. It can hold any string up to and including length 99. Why 99? You need that null terminating character at the end. Right? But the actual length of this string is what? I don't want to force you to go through and count it, so let's find out. Printf, length of my name is going to be %d and the line n. And let's see what this does. Oops. Size 20. No, it saved, didn't it? Okay, so it's having a hard time saving here. I'll go ahead and copy that, get rid of you, don't save you. All right, there we go. All right, so now, retry. Okay, wow. All right, then we're switching over to a different demo. Don't save that one. Let's go ahead and go over to this class and bring up your demo. I'll go ahead and get, oops, nope, I don't want to get rid of everything. Wow, it's really having problems today, isn't it?
Still left, I think.
All right, you're getting refreshed. And then we're going, oh, that's just a solicitation to pay them. No. All great things in life are free. All right, there we go. All right, so let's go ahead and see what this does. So it's of size 100, right? But only my name, and then you've got a whole bunch of room to expand over here if you want to, right? And if I compute how the actual length of that, well, here, now we can predict, because it's visualized here, how big is it going to be? 25? Remember, you start at 0, so it's going to be 26. There we go. And it prints out that the length of my name is 26. It did not count that null terminating character right there at index 26. Right? So it's not going to count that for you. But that's a way that you can determine how big a string is. How do you think it works? All it does is it starts at the beginning of the string and starts counting 1, 2, 3, 4 until it sees this null terminating character. So if there's not that null terminating character in there, guess what? It just keeps going until it hits a 0 byte. So it does have to be a validly null terminated character, but it doesn't include that in its computation. There's another operation called string concatenation. This is taking one string and appending it to the end of another string. You can combine two strings into one, and that using strcat. Right? Here is the signature of that function. Right? There we go. And it has basically the same signature. You've got a destination, and then you've got a source. But instead of copying over the source into the destination, it appends it to the end. Right? It appends the contents of source to the end of the destination string. Right? Once again, you have your assumptions. If it assumes that destination is large enough, it assumes that source is properly null terminated, and if so, it takes care of the null terminator for you. Right? Let me show this in action, see if we've got our CS50 IDE back up. Okay, reload. Maybe it's not going to work at all today, so I'll have to work exclusively over here in Python Tutor. All right, so I forgot my last name. All right, there we go. And hello, whatever. I'm going to go ahead and append, or strcat, concatenation, into my name, my last name. And then let's print that out again. Okay. Visualize this. Are you back yet? Nope. All right. So before I hit it, what's it going to print? Christopher Michael Spaceberg? No, it's not. It doesn't put spaces in there for you. It puts null terminating characters in there for you sometimes. Right? But it ended up appending to the end of Michael here my last name, putting in the null terminating character for me. Right? So if you want to have it append, you need to literally append a space there. Okay? How would I do a space? Is it like this? Here, I'll ask this question. Is it like this? I mean, a space is just a single character, right? But that's not the signature of this function, is it? It's expecting a full string, a char star. So this won't compile, but that will. So you can have a single character in a string. It's just a string of length 1. Okay? And now this will output my correct name with a space there for it. Right?
Can you do that all in one line? Space.
You could have, yeah. You could have put in like a space right there instead, right? All right. Taking too long. Gave up. Right. All right, so I'll put that in the notes at least. I'm pretty sure that that's correct code. I don't see any problems with it. Right, there you go. All right. All right. Let's see. Yeah, let's switch over to Java really quick here. So Java, right? In fact, where's my Java stuff? Strings in Java. Here we go. So strings in Java. Right. Strings in Java are built in. They are not a first-class citizen because it is in the standard library, oops, sorry, why is it not going down? There we go. They are built. There is a full class called string. Right? You also have a string library attached to it that you can manipulate those strings, except that it's not a string.h library that you bring in. It is the string itself. So if you've got a string and you want to call a function that manipulates that string, actually there is no manipulation of it, but all you have to do is whatever that string is, dot, and then whatever function you want to call. Okay? Java strings are not null terminated, right? So you don't have to deal with those kind of things. In fact, don't. Do not try to muck with the null terminating character in Java at all, because it will perceive it as a valid character. So for example, if you had hello, H-E-L-L-O, and then a null terminating character in Java, that's of size 6, right? Because there is a null terminating character at the end, even though you can't see it, right? Another big difference is that in Java, strings are immutable. Once they are created, their contents cannot be changed, no matter what. Right? Now, this might come as a surprise because you've probably done something like this before, but let me show you what I mean. So let me go ahead and create a string name is equal to Christopher, there, just me, there we go. And let's go ahead and manipulate name. Name dot to uppercase. There we go. So what do you think that does? converts all the characters into uppercase. The capital C stays the same, the lowercase h becomes a capital H, et cetera, et cetera. The space stays the same as well. So let's go ahead and try to print that out. System.out.println name. I'm going to print it out before and after I called that to uppercase. It didn't change, right? I didn't lie. It is immutable. You cannot change it. What this does, if I look at the documentation in RTM, is it returns a new string that is the old string all converted over to uppercase characters. So string foo is equal to that. And I'll show you here that the name is the same again, but that foo is a brand new string with different contents that has all been converted up to uppercase there. All right? All right. Okay. Go ahead and email me. You can find me online. There's some random folks on the internet there. All right. Anyway, go back to this. Right. So to uppercase, it does not change. It is immutable. You cannot change them. Right. And actually, this is a very good thing. Hopefully, you've started going through those PDC modules. Right. If you're not, then do so now that exam 2 is over. You should do so. In fact, I invite you to do so before the break. The Thanksgiving break, because with PDC you won't get direct contact with this concept, but multi-threaded programming, right, where you've got a thread and a thread A and thread B, and they're acting on the same data, right? They can step on each other's toes. If A comes in and changes this data at the same time that B is reading it, now they've got a conflict, right? And so one way of avoiding that conflict is by making the data immutable, so that you can read it, but nobody can change it, right? And immutability is a very good thing because it basically gives you thread safety for free, right? And so all of Java's objects are immutable that are built in. There are some that are mutable and can be changed. We'll talk about those later on, but the basic ones are all immutable. You can't change them. Why? Because they were thinking ahead towards a world where everything is multi-threaded. Right? And so they wanted to make sure that everything was thread safe from day one. Right? All right, so like I said, they are immutable. However, all of the methods return new strings. Right? You can determine the length of a string using .length. Right? You can copy a string using the reassignment operator. Right? You can concatenate using the concatenation operator. So all those things that we just did are going to be way easier in Java because it's got this built-in, actually I think I would call it a first-class citizen because it does have this operator overloading here where if you use it with a string in a string, it implicitly means concatenation together. Okay? Let's go ahead and play around with these. Right? Let's start with a string. Let's go ahead and go with name first. Name is equal to, I don't know, Jill Tracy. That's who was playing in the beginning there. Right? So now, does that change the contents of name? Remember, they're immutable. Can you do that? No. All this is doing is creating a brand new string, creates a brand new string in memory, and resets name to point to it. Now, we don't have pointers in Java, but we do have references. To reference it, maybe is better. Reference it. There. So what happened to that old name, my name? It's still there somewhere in memory. Nobody's referencing it, so it becomes eligible for garbage collection. And the Java virtual machine takes care of it for me. If I had done something like this, say string old name, and I reset it to name, and then I reset name to Jill Tracy, right, then you'll see that there's a difference between old name, old name, and the new name. Right? You'll see that the old name is still my name, right? All lowercase, oh, not all lowercase, but lowercase versions, and then Jill Tracy is the new name. Right? This does not reset the contents. This resets the pointer, the reference to a new string. Let's find out how many characters are in my name. So int n is equal to old name dot length. Actually, let's go with Jill Tracy's name there because it's easier to count. I count 4 plus 1, the space, and then 1, 2, 3, 4, 5. So I count 10 there. Do you count 10? All right, system.out.println, n. And Jill Tracy has 10 characters in her name. It also does not count the null terminating character. Why? In Java, there is no null terminating character. Okay? All right. What about concatenation? String. All right, let's go ahead and reset my name to be Chris. All right. Oh, no, I want my full name. Name is equal to name plus Topher. There we go. Oh, no, I want my full name there. Name plus, I want a space. Name is equal to name plus, and then I want my middle name. Right. Let's just go ahead and do it all in one shot. There we go. And if I print this out again, now my name is back to my full name there. So plus, plus, plus. All it's doing is creating new strings all over the place. In fact, Chris is a new string, Topher is a new string, space is a new string, Michael Burke is a new string, and then it's creating a new string on every single one of those lines. Right? So it's creating a lot of objects in the background. In fact, this isn't actually even the code that gets executed or compiled. It changes this code to a series of the following. String is equals to, a new name is equal to new string of Chris dot append Topher dot append. It should be append. What is it called? No, what is it? Dot. I thought it was append. Concat. Concat, I guess. Concat. Concat. Space. Dot concat. Michael Burke. There we go. And there's the new name. So what happens is that it actually translates this plus because it's not. Plus means what? Well, in this context, it means concat, but in reality, what does it mean? Add, right? So we have a plus here that means two different things in two different contexts. We don't like that. That's called overloading, or overloading, operator overloading. Java does not allow that except in this one instance to make everything really, really simple. Right? So what happens is the compiler says, no, we don't like that. That means plus. I will change your code to something that looks like this. And now there's no plus here at all. And plus always means addition. Right? There are some languages, C++, unfortunately, where you can take any operator at all, plus, minus, addition, integer division, whatever, and you can change its meaning. You can change its meaning to a different context. What does it mean for a list plus a list? Does it mean appending them? Does it mean vectorized addition? Does it mean union, right? So I have no idea, right? That's why it's kind of a bad idea in C++ to do stuff like that. And it's not something that Java allows you to do at all. It's not something that C allows you to do at all. Right? But this is basically what happens in the end. Right?
Isn't that a problem that like JavaScript runs into with plus and minus and comparing numbers and characters and integers?
Yeah, with more so with mixed types. For example, in Java, let's take another example here. String foo is equal to hello. Int bar is equal to 42. String baz is equal to, did I already use foo? Okay, what comes after foo? Bar, baz, biz, there we go, is going to be bar plus baz. Now what does that mean? It works. System.out.println biz. It means concatenation in this case. There we go. Hello 42. How did it determine that that was concatenation? It saw that this was a string. Oh, this is an integer. That's not a string. I can't concatenate those two things together. So what it does is it changes your code to toString. Right? Actually, it changes it to integer dot toString. Passes through baz. So now what is this? This is a string plus a string. and then it changes your code yet again to something that looks like this, right? And that's why it works with mixed, these are called mixed types. When you've got an integer and a string, those are two different types. Integer and an integer, that makes sense. Double, double, that makes sense. Add, add. But in this case, it's a string and then something that's not a string. So it will convert it to a string in order to be able to concatenate it. Exactly the opposite happens with respect to PHP. Right? That's not a language that we're going to cover, but what it does is it tries to take the string and convert it into a number, right? If it can, cross your fingers. Likewise, JavaScript does something like that. It tries to convert it, the best effort convert or whatever, it's called type juggling, right? It juggles it up in the air and hopes for the best. Usually, it's not a good juggler and all the balls will fall, right? And so you do have to be explicit and very, very careful with stuff like that. Less so of an issue over here in Java because, of course, if any one of these operators or operands are a string, it will automatically convert it to concatenation. Right? But yeah, you've got that. All right. Oh, 10 minutes left. Let's do one more thing. In Java, you do have a mutable version of a string. This is actually probably what it converts to here is it creates what's called a string builder. String builder, SB is equal to new string builder. Now this is mutable. You can do whatever you want with this. SB.append. This is what I was thinking of with append. Here's my name, Chris. Right? SB.append, Topher. Right? SB.append, space. And then you can also append after that. So you can, this is called, this thing up here that I was doing, concat, 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 that's called chaining, right? And in fact, a lot of people will actually put these into multiple lines like this so that it looks something like that, right? So let's append something else to this. Michael dot append space dot append. There we go. Right. In fact, let's go ahead and misspell this, C, and I'll show you what else you can do with it. Again, this is called chaining, where you can call this series of append, append, append. Right? Now what you can do is you can dump it to a string. So string foobar bazbiz buzz is equal to sb.toString. Right? Now it becomes immutable. Buzz is something that you cannot change. But you can still change your string builder. Let's go ahead and spell my name correctly. SB dot, what is it, replace? Yep. I will replace the thing starting at 0 of size 1 in buzz to capital C. There we go. A-E-I-O-U, I'm at the end, so bzz, there we go. I'm running out of, I should have just started with A, B, C, D, E, F, G, right? So system.out.println buzz, and then bzz. There we go. There. It dumped to a string which was immutable, cannot be changed, but your string builder can still be changed. You can replace this character here with that character there, with the uppercase C. Right? This actually replaces an entire substring. So if I'd gone from 0 to 10, for example, and it was like Jeremy, I don't know why that came to my head, but whatever. There we go. There, we replaced Christophe, and not the R there, with Jeremy. Right? So 0 through whatever index you want, we should have gone up to 1 or 11 there, in order to get all of the my first name. There we go. Jeremy Michael Burke. I don't have any relatives named Jeremy, right? Okay. So that is your primer on strings in Java. By the way, that's not the only thing you can do. Let's go ahead and go with biz.look at all of those functions. There are dozens and dozens and dozens of functions that you can call in this, right? Basically, anything that you can do in the C standard string library, you can do with here, and an equivalent here with more. Right? You want to convert it all to uppercase characters, all lowercase characters. You want to substring out of it. You want to do a bunch of manipulations and stuff like that. You've got dozens and dozens and dozens of different functions that you can do here. In fact, when you get into your lab and your hack this week, really think about this, because most of those solutions are going to be one-liners that you can use the string library for in Java. It's not going to be necessarily that easy in C, but it can always be easy, right? All right, so I'll put this all into the notes so that you have it. Any questions on strings in either language so far? No? Okay. Then on Wednesday, we'll come back and we'll start doing some more things. For example, byte-limited versions of these things. What if you only want to copy the first 5 characters of a 10-character length string? Or what if you wanted to copy these middle 5 characters over here? My middle name, Michael, I wanted to copy that over instead, right? You can do that in both languages. Those are called substrings, right? And we'll talk about how to do that in C and Java on Wednesday. Yeah,
Can you scroll back up to the string length and the string category?
sure. Here? Or more up?
So that the code block is just off screen.
This one?
No. Back to where you were.
Okay.
Just slightly up.
Slightly after? In strings in Java, you mean?
No, like back code block just off screen at the bottom.
There?
Enough so that
Up or down?
one block is no longer
Up.
go up.
Right
Stop.
Okay, there we go. Thank you. Sorry. All right, I'll see you on Wednesday.